Hello and welcome to day 25 of Jamb Mathematics in 30 days. It has been a very wonderful experience so far. So I'm saying a big thank you to each and every one of you that has been part of the series from day one up until this moment. It's day 25. We are almost there. So don't get tired. Don't relent now. We just have a few more days to go and then the series would come to an end. And please don't forget, the aim of this series is to ensure that you are equipped daily with every necessary tool you need to ace Jamb Mathematics. So if you are one of those who dreads Jamb Mathematics, that thinks it's such a difficult thing to do, well, this changes the narrative, because as you follow the series to the end, every day you are becoming better at facing the challenges of Jamb Mathematics and coming out in flying colors. So if you are yet to subscribe to the channel, please do so, and also click the notification bell so that you would be alerted every time we put out a new content for you. And also don't forget to join the challenge on the Exam Fund app. The 30 days challenge is going on there and it's going strongly. So participate and earn prizes as you learn. So today on day 25, what we'll be doing is solving many more questions also that cuts across the topics in the Jamb syllabus. For those that have seen day 24, we're doing practically the same thing today, but with different questions now, so that the amount of questions we have solved before the exam will continue to grow, and then we get better as we do so. And don't forget, I will also be giving you tips as we solve those questions so that you can gather more knowledge on solving specific problems in some specific topics. So I hope you're ready. Get everything that you need, your writing materials, and then let's solve problems. Now, this math problem involves logarithm of an unknown base, and is equated to that has a known base of 5. So how do we solve this problem? So we are told if 6 log to base x of 2 minus 3 log to base x of 3 equals 3 log to base 5 of 0.2, what is the value of x? Now, one thing you want to do is to first apply the laws of logarithm to simplify this problem, and then we'll see how we can get the value of x from that. Now, starting with this, when you have a log to a base of 2 like this, what happens is that this comes here and becomes the power here. So we're going to be having log to base x of 2 raised to the power of 6, right? So here we then have minus, the 3 goes here, so we'll be having log to base x 3 cubed equals, now 2 over 0.2, I mean 0.2 is the same thing as saying 2 over 10, which will give you 1 over 5. So let's do that here. We'll have log to base 5 of 1 over 5, and then we cube that. So when we are working with this, now I'm saying something at this point that we need to address. Whenever you have log to base a of a raised to power minus 1, what we actually have here is minus 1, right? So meaning I could have written this in a different way. So let's solve this part first though. What is 2 raised to the power of 6? So 2 times 2 gives us 4, times 2 we have 8, times 2 we have 16, times 2 we have 32, and then times 2 we have 64. So this will give us log to base x of 64 minus log to base x of 3 cubed, that's 27. So let me write the 27, good. Now equals, now if we apply that rule here, 1 over 5 is the same thing as saying 5 raised to the power of minus 1, right? So what we'll have is this 3 comes back and then the minus 1. So we have 3 times minus 1 at this point. So that way we have solved this part here. Now let's continue with this. Now when you have log of the same base and then you are subtracting them, what happens is that you can take one of them and say log to base x, and then you divide these two. So that is 64 divided by 27. So now that we have this, we then equate this to what we have here is minus 3. So what does this mean in mathematics? It means that x to the power of minus 3 equals 64 over 27, right? So let's write this so that it will have the same base, the same power rather, as x. So from here we can say x to the power of minus 3 equals, now 64 can be written as 4 cubed. And 27 can be written as 3 cubed. So 4 over 3 cubed. Now if you observe, this is negative, this is positive. So to make this negative, we have to flip this. So we say x raised to the power minus 3 equals 3 over 4. Now raised to the power of minus 3. So now that they have the same power, then we can say x is 3 over 4. So the correct answer is C. This question says a solid hemisphere has a radius of 7 centimeters. Find the total surface area. Now, the total surface area of a hemisphere is given as 3 pi r squared. So, in our solution, we apply that total surface area equals 3 pi r squared. This is for hemisphere. So, applying this, we would have 3 times pi is 22 over 7 multiplied by r squared, so that is 7 times 7. So 7 cancels 7. 3 times 22 will give us 66 times 7. This is in centimeters squared. So let's find out what this would be. 7 times 6 is 42, so 2 carry the 4. 42 plus 4, and that's 46. So 462 centimeter squared. That is option B. An unbiased die is rolled 100 times and the outcome is tabulated above. So what is the probability of obtaining 5? If you want, you can confirm the sum of these to be 100. So, but we already told in the question that all of this sums up to 100. So the probability of obtaining 5 is going to be the number of times that 5 was gotten, and we can see 5 was gotten 20 times, over the total outcome. And the sum of all these outcomes here is 100 according to the question. So when we solve here, we see that 20 goes in 20 once and 20 goes in 100 5 times. So our answer is 1 over 5. A. If P varies inversely as the cube of Q and Q varies directly as the square of R, what is the relationship between P and R? If you are here to subscribe to the channel, please do so. Subscribe to the channel right now and also click the notification bell icon. That way you always get alerted every time we put out a new content for you. So to solve this problem, we start with the first statement. We're told that P varies inversely. So that will be 1 over cube of Q. So Q raised to the power of 3. Now what this implies is that P will equals, so let's call this constant 1 over Q cube. Okay? Now to the next statement, we're told Q varies directly as the square of R. So Q is square of R, and this implies that Q equals, so let's call this K2 and then R squared. Now when you look at equation 1, we have Q there, so we can substitute. So if we call this equation 1, equation 2 here, this equation 1, all we have to do is substitute equation 2 into 1. So in place of Q in equation 1, we're going to put K2 R squared. So from there we can then say P equals K1 over, so instead of this we're going to be having K2 R squared all cubed. Now this will give us K1 over K2 cubed R. Now 2 times 3, that is 6. So from here we can say that P therefore varies inversely as R raised to the power of 6. So which of them says that? So P varies inversely as R raised to the power of 6. So our answer is option B. If the operation on the set of integers is defined by P times R to give us square root of PQ. Now this is binary operation. So we have to find the value of P into 4 into 8 times 32. So to solve this, we'll first apply this rule to this bracket. Then what we'll get to then apply it to the whole thing in the end. So solution. We'll start by saying 8 and 32. Now this would give us, according to the rule, the square root of 8 times 32. Now this would give us, now I can rearrange this and say 8 times 2, which would be 16 times 16. So our answer here would be 16, because square root of 16 square is 16. And then what we'll now have will be 4 and 16, which would then be square root of 4 times 16. Now square root of 4 is 2, square root of 16 is 4, and 2 times 4 will give us 8. So the answer is 8, which is option A. Now this question says we should divide 4x cubed minus 3x plus 1 by 2x minus 1. Now here's what to do. So when you are dividing polynomials like this, ensure that you have all the powers of x from the highest to the lowest. So that is, here we're going to have 4x cubed, right? There's no x squared here, so we have to introduce x squared by saying plus 0x squared. Now 0x squared is still 0, so we haven't changed the equation in any way. I mean, we've not changed the expression rather in any way. So then we follow up and then say minus 3x plus 1. Now we are dividing this by 2x minus 1. Now what multiplied by 2x will give us 4x cubed. So that will be 2x squared. So 2x squared times 2x will give us 4x cubed, right? Now 2x squared multiplied by minus 1 will give you minus 2x squared. Now at this point we subtract. When we subtract here, this will give you 0. Now this will be 0 x squared minus 2x squared. That will give you plus. So plus 2x squared. Now we'll bring this down. So minus 3x plus 1. Now what multiplied by 2x will give us 2x squared? That will be x. So we say plus x. Now x times 2x will give you 2x squared. Now x times minus 1 will give you minus x. So subtract. When we subtract here, this is 0. Minus times minus becomes plus. So 3x plus x will give us minus 2x. And then this comes down plus 1. So what can go again? That will be minus 1. Minus 1 times 2x will give you minus 2x. And minus 1 times minus 1 will give you plus 1. And when we subtract at this point, this is 0. And this will also be 0. So we are done. There's no remainder at this point. So our answer is 2x squared plus x minus 1. Plus x minus 1. So that is D. The solution of the quadratic inequality x squared plus x minus 12 greater or equals to 0 is. So we're going to solve this quadratic inequality and then find the values of x. So what we have here is x squared plus x minus 12 greater or equals to 0. Now we need factors. Now we know that what we have here is minus 12 multiplied by 1 and we still have minus 12. So our factors has to give a product of minus 12 and a sum of plus 1. And to get that we need minus 3 and plus 4. Because minus 3 plus 4 is 1. And then minus 3 multiplied by plus 4 is minus 12. So this can now be written as x squared minus 3x plus 4x minus 12 greater or equals to 0. Now we group this. What we have in common here is x, leaving us with x minus 3. And then here we have plus 4. So x minus 3 greater or equals to 0. So we can now say x minus 3 is greater or equals to 0, or x plus 4 is greater or equals to 0. So from here we see x is greater or equals to plus 3, or x is greater or equals to minus 4. So greater or equals to plus 3, greater or equals to minus 4, plus 3, minus 4. So that is option B. Let's rationalize 2 sod 3 plus sod 5 all divided by sod 5 minus sod 3. To rationalize, we're going to multiply the numerator and denominator by the conjugate sods of the denominator. So, solution. So all we'll be having is 2 sod 3 plus sod 5 multiplied by sod 5 plus sod 3, which is the conjugate sod of this denominator, divided by sod 5 minus sod 3 multiplied by sod 5 plus sod 3. Now this would give us 2 sod 3 times sod 5 will give us 2 sod 15. Now 2 sod 3 times sod 3 will give us 2 times 3, which is 6, so plus 6. Sod 5 times sod 5 will give us plus 5. And then sod 5 times sod 3 will give us plus sod 15. All divided by, now sod 5 times sod 5, that is 5. Sod 5 times sod 3 will give you plus sod 15. So minus sod 3 times sod 5 will give us minus sod 15. And minus sod 3 times plus sod 3 will give us minus 3. So let's simplify. At this point, we have 2 sod 15 plus sod 15, which will give us 3 sod 15. Plus 5 plus 6, that is plus 11, over, now, sod 15 minus sod 15, that's 0. And 5 minus 3 will give us 2. So we have 3 sod 15 plus 11, all divided by 2. That is option A. Evaluate integral to upper limit 2 and lower limit 1 of 5 over x with respect to x. Now, let's simplify this. We can then say integral lower limit 1, upper limit 2. This can then be written as 5x raised to the power minus 1 dx. And then this comes here, so we'll have 5 integral x raised to the power minus 1 dx. Okay, so at this point, we can then try to resolve this. Now, we know that whenever you have d dx of, like when y equals to ln x, then dy dx will give you 1 over x. So therefore, if we should integrate this, it will take us back to this. Therefore, integrating this would give us 5 multiplied by, now this will give us ln x. And then we take limit, upper limit 2, lower limit 1. Now let's resolve this. What this means is that we are having 5 into ln when x is 2 minus natural log when x is 1. Now this will give us 5 into, now natural log of 2 is going to give us 0.693 minus natural log of 1 is 0. So basically we have 5 multiplied by 0.693. And when we multiply this, we're going to have 3.466 and on like that, which is approximately 3.47. So the answer is D. Solve for x and y if x minus y equals 2 and x squared minus y squared equals 8. So we see that this is an equation that we have to solve simultaneously, noting that one of them is linear and the other is quadratic. So let's solve. So x minus y equals 2, we call that equation 1. And then x squared minus y squared equals 8, let's call that equation 2. Now from equation 1, we can say that x equals 2 plus y, right? So we call this equation 3. Now all we have to do is substitute equation 3 into equation 2. So substitute x equals 2 plus y into equation 2. So when we see x here, we'll replace it with 2 plus y. So it's squared, so we multiply by itself, 2 plus y minus y squared equals 8. So let's expand. 2 times 2, 4. 2 times y, that's plus 2y. Y times 2, that's plus 2y. Y times y, that's plus y squared. Then continue, we have minus y squared equals 8. Plus y squared minus y squared, that's 0. So what we have here is 4 plus 2 plus 2, that's 4. So we can say 4y equals, now when this goes here, we have 8 minus 4. So 4y equals 4, which implies that y is 1. So now that we know the value of y, let's solve for x. To solve for x, we say x equals, now we have 2 plus y. Y is 1, so x is 2 plus 1, which is 3. So our answer is 3, 1. That is option B. Let's simplify this expression. We have 7 whole number 1 over 12 minus 4 whole number 3 over 4 plus 2 whole number 1 over 2. So solution. First, we can arrange it according to BODMAS. And then we have 7 whole number 1 over 2 plus 2 whole number 1 over 2. This is over 12, I mean. Then minus 4 whole number 3 over 4. So now let's convert all of them to their improper fraction. Now 12 times 7, that will give us 84. 84 plus 1, and then we have 85 over 12 plus 2 times 2, 4 plus 1, that is 5 over 2 minus 4 times 4, 16. 16 plus 3, that is 19 over 4. Now when we take LCM, LCM will be 12. And then 12 and 12, 1 times 85 is 85. Plus 2 in 12, 6. 6 times 5, 30. 4 in 12, 3 times 19. Let's see. 19 times 3. 3 times 9 is 27. 2, 3. 3 plus 1, 5. So we have 57 here. Now this would give us 85 plus 30, that's 115. So minus 57. So 15 minus 7, that is 8. And then 10 minus 5, that's 5. So we have 58 over 12. Now, how many times can 12 go in 58? Now, 12 times 4 would give us 48, right? So 4 whole number with a remainder of 12 times 4 is 48. So 48 out of this, that's 10. 10 over 12. So this can then be written as 4 whole number. 2 can go. 2 here, that is 5. 2 here, that is 6. So 4 whole number, 5 over 6. So option C. So in this question, we have two 3 by 3 matrices, X and Y. And we are asked to find 2x minus y. So to do that, we first find the value of 2x. So 2x is 2 multiplied by matrix X. So let's repeat what we have in matrix X. So 0, 1, so 1, 0, 1, 2 minus 1, 0, minus 1, 0, 1. So this would give us 2 times 1, that's 2, 2 times 0, 0, 2 times 1, 2, 2 times 2, 4, 2 times minus 1, minus 2, 2 times 0, 0, 2 times minus 1, minus 2, 2 times 0, 0, 2 times 1, 2. So this is 2x. So now let's evaluate 2x minus y. That is, we are having this, which is 202, 4 minus 20 minus 202, then minus y, minus 1, 1, 2, 0 minus 1 minus 1, 2, 0, 1. So let's solve that part. This will give us 2 minus minus 1. Now minus times minus becomes plus, so 2 plus 1, 3. To the next element, 0 minus 1. That will give you minus 1. Now 2 minus 2, that's 0. Now to the next row, 4 minus 0, that is 4. Minus 2 minus minus 1. So minus times minus becomes plus, so minus 2 plus 1 will give us minus 1. 0 minus minus 1. Minus times minus becomes plus, so 0 plus 1, 1. Minus 2 minus 2, that is minus 4. 0 minus 0, 0. 2 minus 1, 1. So we have 3 minus 1, 0. 4 minus 1, 1. Minus 4, 0, and 1. So when we look carefully, okay, we will see that the correct option is B. This question says to calculate 243 base 6 minus 243 base 5, expressing our answer in base 10. Now, they are not in the same base, so we cannot subtract them directly. So in order to subtract them, we have to convert each of them to base 10. And good, the question itself says we should express our answer in base 10. So when we do that, we can then subtract the result of converting each of them to base 10. Then we get our final answer. Let's start with 243 base 6. Taking this to base 10, we're going to be having 2 times 6 plus 4 times 6 plus 3 times 6. So this power will be 0, 1, and then 2. 2 squared, that is 36. 36 times 2, and we have 72. Plus 4 times 6, that's 24. Plus 3 times 1, that's 3. So let's add this up. This would give us 96. 96 plus 3, that's 99 base 10. Now we have 243 base 5. Let's take that to base 10. So this will be 2 times 5 plus 4 times 5 plus 3 times 5. So 0, 1, 2. 5 squared is 25. 25 times 2, and we have 50. Plus 4 times 5, that is 20. Plus 3 times 1, that's 3. So what we have here is 73. So all we have to do now is 99 minus 73. And this will give us 9 minus 3, that's 6. 9 minus 7, that is 2. So our answer is 26 base 10. So we pick option C. Find the gradient of the line passing through the point minus 2, 0 and 0, minus 4. So we call this x1, this will be y1, and then this will be x2, this will be y2. So let's solve. The gradient will therefore be y2 minus y1 over x2 minus x1. Now, y2 is minus 4 minus y1, 0, over x2, 0, minus x1, minus 2. Now, this would give us minus 4 over 2. So, our gradient is therefore minus 2, and that is in option C. In this question, we see that from a point P, R is 5 kilometers due west and 12 kilometers due south, and we are to find the distance between P and R. So let's visualize this so that we can solve without problem. So let's take point P, and we know that point R is going to be due west and due south. That is, we are looking at the southwest. So southwest of P. So if this is point P, This is south, this is west. So due west, we have 5 kilometers. And then due south, we have 12 kilometers to arrive at point R. So all we need to do is combine this now and then look for the distance between P and R. So this would give us a right angle triangle, and then we can apply Pythagoras. So applying Pythagoras, we'll have that this distance here, which is PR squared, would be 5 squared plus 12 squared. So PR squared is 25 plus 144. And this would give us 169. So the distance PR would then be the square root of 169, which is 13. And they are measured in kilometers, so 13 kilometers. The correct option is C. The variance of x, 2x, 3x, 4x, and 5x is, so we are looking for variance in this question. That's what we want to solve for. And variance V equals summation x minus x bar in bracket squared all over n. So we need to find x minus x bar. That means we need x bar as well. So let's create a table to make this easier. So our x are all these values that we have here. So we have x, we have 2x, 3x, 4x, and 5x. Now x minus x bar would be then x minus x bar squared. So let's find this. We see that we have n to be 5 anyways, but to find x bar would be the sum of all of this. So x plus 2x, that's 3x, 3x plus 3x, that's 6x, 6x plus 4x, that's 10x, plus 5x, and we have 15x divided by 5, and that will give us 3x. So that's the mean. Mean is 3x. So x minus the mean will give us minus 2x. 2x minus this will give you minus x. 3x minus this, that's 0. 4x minus this will give you x. 5x minus this will give you 2x. So now let's square it. Here we then have 4x squared. Here we're going to have x squared. This is 0. This is x squared. And this is 4x squared. So let's sum it. The sum of everything here would then be, recall this is 4. So 4 plus 1, that's 5. Plus another 5 here, that's 10. So we have 10x squared. So variance would therefore be the sum of this, which is 10x squared, divided by n, which is 5. So variance equals 10 divided by 5, that is 2, then x squared. Option B. In this question, we are to find A intersection B. That is what set A and set B have in common. Given that set A consists of 3, 4, 1, 0, and 1 over 3. And set B consists of 4, 3, 1 over 3, 1 over 5, and 7. So let's look at what they have in common. That is A intersect B would therefore be, now set A has 3, set B also has 3. So that would be 3, comma. Set A has 4, set B has 4, so 4, comma. Now 1, set B does not have 1. Set A has 0, set B does not have that. And then set A has 1 over 3, which is also in set B. So our answer is 3, 4, 1 over 3. So we have it as option C. We are to integrate x squared minus square root of x over all divided by x with respect to x. So this is how we solve that. Integral x squared minus, this can be written as x raised to power half all over x, all with respect to x, so dx. To start with, I will have integral, then we have x squared over x, distributing the denominator. Then this will be x raised to the power half over x. So now what do we get from here? Remember, we are still doing this with respect to x. So from here we see that we'll have integral x, because x cancels this, minus this one will now give you x raised to the power minus half all dx. Now if this were minus 1, this part would have been in x, but it's minus half, so we can go on to integrate applying the normal integration rule. So from here we would have x 1 plus 1 over 1 plus 1 minus x raised to the power minus half plus 1 over minus half plus 1. All of these plus constant k. Now this will give you x squared over 2 minus, now this will give you x raised to the power half over, this one will then give you 1 over 2, all plus k. Now when we try to resolve this, we see that we have x squared over 2 here. Now this 2 goes up, so minus 2, and x raised to the power half is the same thing as saying square root of x, so over 1, so it remains the same, so plus k. So x squared over 2 minus 2 root x plus k, that is option A. So that's our answer. The mean of 2 minus t, 4 plus t, 3 plus minus 2t, 2 plus t, and t minus 1 is, so to find the mean, here's what we do. Mean equals the sum of everything here, so 2 minus t plus 4 plus t plus 3 minus 2t plus 2 plus t plus t minus 1 all over, now 1 2 3 4 5, so all divided by 5. Now let's add carefully, starting with the numbers. So 2 plus 4, that's 6, plus 3, we get 9. 9 plus 2, that's 11. 11 minus 1, that's 10. So 10. And then minus t plus t, 0. Minus 2t plus t, that's minus 1, that's minus t. And minus t plus t, that's 0 also. So 10 over 5. And this will give us 2. So the mean is 2, option C. Find the range of values of x for which 7x minus 3 is greater than 25 plus 3x. So let's solve this inequality. 7x minus 3 is greater than 25 plus 3x. So collect like terms, and then we have 7x plus 3 becomes minus 3x, and it's greater than, we have 25 here. So when this comes, it becomes plus 3. Now let's see. What we have here is now 4x greater than, when we add this, we get 28. Now divide both sides by 4, and x is greater than 7. So the correct answer here is in option A. Now, there are so many other questions you can always practice with to get better daily. And one of those ways to continue to practice and improve your skills in mathematics especially is by practicing on the Exam Fun app. And good news, the Exam Fun app is currently running a challenge where you do 30 days of mathematics to earn wonderful prizes. So take part in that challenge by downloading the Exam Fun apps, registering, and playing on. I'll see you in the next video.